Hey guys, we are doing 1.06, the On Your Own practice. We're starting with number 1. So which transformation is shown in this figure? So pay special attention to this arrow. So what happens to it? So it's pointing up this way, and now it's pointing this way. That could only happen if we went around in a rotation. So let's try that. So if we rotated this around, then the arrow would be pointing that way over here. Let's check that. That is correct. Let's try the next one. All right. So once again, which transformation is shown in this figure? We're looking at that little arrow. So here it is in the left-hand corner. In the transformation, it is in the right-hand corner. Well, how would that happen? If I reflected this, if this was looking in a mirror, then that's where the arrow would be. If there was a line of reflection right here and it was reflected over it. So let's say reflection. And we're correct. All right. So now, what is the center of rotation for this pair of figures? So it started here at the solid line and goes to the dotted line, which is the transformation. So it looks like it rotated on this point here, T. Excellent. All right, now this one, if we rotate on some points, if we use this point, it would just stay right in this area. The Z is not going to move way up here. If we rotate on any of these points, that's not going to give us, they would have to stay in that rotation. So it has to be this point here. We rotate around this point Q. This would rotate around and fit onto that dotted line. And we are correct. All right, now identify the line of reflection. So remember, when you reflect, the two figures are going to be the same distance away from the line of reflection. So here is touching one of them but not touching the other one, so it can't be B. A is going through one, not going through the other. That's not the same distance, so it has to be C. Great. Yep, and notice it says about the same distance. All right, here's another one that's a little bit harder. Now, once again, we're looking for that same distance. This P is too close to one of the moons. I believe that it's in. Let's try that one. And that's what it is. All right, Charlotte has placed 2 photos on the page of a photo album, but changes her mind and slides, there's your keyword, slides them both to a different place on the page. What type of transformation did she perform? So when you slide, that is called a translation. Let's check that. All right. Micah is straightening up some things in her living room. She turns the table so that it is parallel rather than perpendicular. Turns the table to a wall. What transformation did she perform? Well, when you make a turn, what kind of transformation is that? That is a rotation. All right, which translation vector could be used for the pair of figures? So which way did it slide? So this first one is the down vector. If we slide this one down, it's not going to lay on top of this other pentagon. If we slide, starting up at the top left, going down to the bottom right, top left, bottom right, it looks like D. We can test E. E is going up. From the bottom left to the top right. If we did that, our pentagon would be up here. Let's try D. Oh, great. All right, now we're looking at the heart. Once again, the straight down, if we took this heart and went straight down, it's going to be over here somewhere. The C, if we took the heart and went straight that way, it would be down here. If we did F and went from, I would say, middle right to top left, that's going to be over here somewhere. But E starts at the bottom left and goes to the top right, bottom left, top right. All right, the pre-image was rotated 90 degrees clockwise to produce the image. Okay, so the pre-image here was rotated, counterclockwise, 90 degrees counterclockwise, so this way. So we have two choices for our center of rotation. We have E. Notice how where C is in relation to E. If we went counterclockwise 90 degrees, C would end up here. That still looks like the same length and angle from E. D, point C, if we rotated around point C, D would remain the same distance from C, and we go counterclockwise 90 degrees, it would be somewhere over here, like on top of D. So it has to be point E. Oh, point D, we rotated that 90 degrees around that. F will be down here, not far enough over, and F, that would put this point over here somewhere. So it has to be, sorry, I didn't see those other two. I was reading too closely. Which transformation is shown in this figure? So we could say that it slides over there, but notice how it reflects like you're looking in a mirror, where it looks like it flipped over this line of reflection. And now the small side is on the right instead of on the left. So let's say reflection. And that is correct. All right, which transformation represents a rotation? So this one, the only transformation where an object changes size is a dilation, so that can't be it. This one, if you like clap your hands and then put them back that are on top of each other, you're reflecting them over. Notice how the thumb is on the left and now the thumb is on the right. That is a reflection. Now we're looking at this arrow in the triangle. If we rotated in a perfect circle, notice that the angle would be, the arrow would now be pointing that way if it rotated around. And just to check this one, notice how the arrows did not change directions. If we rotated these, the arrows would be pointing down or more down than they are. They wouldn't stay the same like that. This is obviously a translation where they just slid it up to here. Uh-oh. Oh, I was like, wait a minute, we did select that. Sorry about that. When I was pointing this one out to you, it selected that one. This is our rotation. Sorry about that. All right, which transformation represents a rotation? So once again, we're turning. So this one, all the points stay in the same place. So it just slid or translated over to here. So that can't be it. This one, now the points are facing each other as if in a mirror. So this is a reflection. A's on the left, now A's on the right, reflection. This one, changing size again, has to be a dilation. So let's look at this one. So if this rotated and had a point here in the center that it rotated around, then C would end up here. This is our rotation. Just making sure that's what they want us to pick again. Reading carefully. All right, which transformation represents a reflection? All right, obviously not this one, the dilation, changing size. This one, the arrow rotates around and points the other way, rotation here. This one, the arrows stay the same, so it must have just slid over or translated over. And this one, the reflection, as if these were looking in a mirror at each other, thumb on the left-hand side, now on the right-hand side. This is our reflection. Think about a mirror. All right, which transformation represents a reflection? So once again, this is obviously rotating around, okay? Rotation. This one is changing size, has to be a dilation. This one over here, these points stay in the same place. It must have just slid over or translated over. And here, A is on the left, and now A is on the right, as if it was reflected in a mirror. And that is on your own practice, point 1.06.